All right, welcome to another session of DGX Compare. Today we're working with a model I'm really excited to test, and this is the Nemotron 3.5 Lightning. I'm really looking forward to testing this because this is NVIDIA's latest iteration of the Nemotron models that are compressed down for better usage by consumer GPUs. And this is a 30 billion parameter model. Most of the training was done with their Ultra, Nemotron Ultra, and it's quantized down via NVIDIA FP4, NVIDIA FP4, and it's able to fit in a single DGX device, the left there, which is the DGX Spark. So I don't need to run it clustered, and I'm able to allocate the entire model into memory because it's only 24 gigs on memory for the weights, and the rest is KV cache. So let's give it a quick look. Let's do the typical query. I'm using one hand right now, so let us grab, tell me all about Tyrannosaurus Rex, and give it a try. This is a thinking model, but NVIDIA stated that this will be 4 to 5 times faster than models its size, or similar models its size. And there we go. It's grabbing CPU 8, and there we have it. Wow, that is pretty fast. That's definitely over 50. It looks like 70, 80 maybe, including some graphics on the side. That's pretty impressive. I have this running in the bottom here. This is the kind of a system monitor for the second device there. It's clustered, but it's we're actually running single node. I just want to make sure nothing is getting sent over. But I am a little concerned with the network here. I don't know why the network is actually running, because it shouldn't be touching that environment at all. So we'll look into that a bit later. Let's see a follow-up. How does T-Rex compare to other apex predators like Gigantosaurus or Spinosaurus? Let's give it a click. So still thinking. How fast did it think earlier? It thought for 17 seconds. Let's see how this does. I'm not necessarily impressed with the amount of thinking that it's doing. I'm happy that the decode is fast. This is looking more like 60, not 70 or 80 that we saw earlier, but it's spending a little bit too much time thinking. We've seen faster models, or at least faster thinking with other models. But the data is a lot. I mean, they're actually providing a lot of data. So, it could be a good trade-off there, right? I don't mind it thinking more as long as the data is the correct amount, and impressive for this decode speed. I'm gonna try this a little bit later on our Ultra. We're doing some tests on there, but I think this will even fit inside of the MacBook Pro with 48. So let's compare the results there, or the performance there. Let's do one more. How popular media depictions often get the anatomy and behavior of these dinosaurs? Most common misconception. Okay, that's a good question. While that's going, let's actually work on a new chat, and let's actually prepare for our Python test. And do the same thing on Gemini. Let's grab that file. what we're having it do is compute the mean, median, and max for the MPG column. Oh, we already completed. Yikes. Yeah, that's fine. Let's go to the chat there. And let us paste this in and see how it does with Python. Oops! Oh no, I just realized I actually did not click code interpreter. So this could be a problem. Normally you would want OpenWebUI to be the one doing the actual calls to Python. But let's see what the model does. We've seen it happens where the model actually is able to calculate it properly. I know we've had problems when the model is running out of memory or the file's too big, but it looks here like maybe it can handle an 18K file. So let's see what it does. Normally what we do is we turn this thing on. This is the OpenWebUI code interpreter, and it passes the model will pass the Python calculations and the execution of the Python to the actual interpreter built in with OpenWebUI. But since we forgot to do that, we are now relying on Nemotron to do the calculations for us. And that's what happens. This is a 398 by 9 file, and because I didn't have this on, it's actually unable to calculate it, or doesn't calculate it because it's too big for doing it in the model itself. I know it sounds preposterous that an 18K file is too big, but we've seen this happen. So it actually says, oh, we only did 3. Let's do exactly the same thing. Actually, I'll do it in this chat to see what it does. This time I'll turn the code interpreter on and see if it's able to correct itself. Otherwise, we will do another chat and see it clean. Anyway, well, that's running. Let's kind of discuss the VLLM calls for this. Or sorry, yeah, so this is the Docker run. It's actually not VLLM, as I mentioned earlier. This build actually requires us to be using Docker, so we're actually using it metal. So this is the actual full command to run it. And we're using here 91% memory utilization. The KV cache is FP8. Normally we use NVFP4. Actually, sorry, it's began thinking already. But NVFP8 is the recommended setup based off of NVIDIA's playbooks, so we're using that. And we're using 3 in terms of speculative tokens. So 3 words for speculation. And here it's actually using Qwen3's coder model for parsing. So yeah, that's kind of how it's set up. Okay, there we go. It's still only looking at 3 rows and 9 columns. So let's actually create a new chat. Do the same file. And this time, actually turn on the code interpreter, paste the text in. I'll take a few moments. Oh, there we go. And then actually do the run. So this is a fresh chat, so it's not carrying anything over. Sometimes we've seen it where when you're in an existing chat and you ask for something, it's using that chat's cache. And so when I asked it to recalculate earlier, it's still working off of the 3 rows that it looked at instead of the 398 rows. So in this case, that restriction is not going to be applicable because it's a new chat. Everything else is still stable. It gets crazy when all of these start garbling around, but 1 or 2 CPU cores to do calculations is fine. It's actually expected. Yeah, when you call something lightning, it should really be fast. And as we saw, it's fast in terms of decode. I'm expecting something a little bit better for prefill. It's not a big file. You're not asking it to do much other than to print out the total number of rows and columns and to compute the median, mean, and min and max. And it shouldn't be taking this long. This is looking like, I don't know, a full minute. Oh, 24 seconds. There we go. So there's the code. But it actually didn't execute it, which is disappointing. Remember earlier, it actually did execute it. But I'm actually going to press run here. See what it does. Press run and it prompted me for something. I'll stand it out. Interesting. Yeah, it's actually not executing the code. Not happy with this. At least can you show me the first 3 rows of the data set? Okay. Okay, at least do that. Ah, this isn't great. So 24 seconds for it to generate pretty basic code and not even execute it. And this is, it already has it in cache or in memory, or at least chat memory. It's still thinking this long just to get the first 3 rows of the data set. Okay, good. At least I got that. But remember, right, the previous tests were only able to get 3 rows. Again, I just wanted to see it tell me 398 by 9. How many total rows and columns in file? I'm going to copy this prompt and we'll do another chat if this doesn't throw me the correct information. But if that doesn't do it, that's really disappointing. Because if you can't get me a basic, breakdown of a 18K file, it's not really useful for work. And this is really bad. And again, we've allocated 128 gigs to memory, so you can't do anything else. And the weights itself are like 24, so everything else is on cache. So this should really be lightning, right? And it is not. Yeah, it's only able to see for the exact data set. The standard data set typically contains, right? But it's saying it's an extracted context snippet. That's actually not true. We gave it the full file. Okay, last chance. We're gonna do the file again. And 18K. And all I'm going to do is ask it how many total rows and columns in this file. This should not be hard. Now, for those who are new, FLAC files are treated a lot differently than CSV files. CSV files, because of all the commas, the tool has to spend extra time to parse out. They'll have to go through the entire file to determine what rows and what columns are. And that's why it takes quite a bit of a long time compared to a typical FLAC file, because they have carriage returns. But here, when you have what supposedly is a fast model, you can expect more. And I'm not necessarily seeing that. And again, it's only able to spot the 9 columns, and it's actually guessing now, right? It's saying, oh, it's a well-known thing. I'm not asking you to do the well-known thing. I'm actually having you analyze this file. And I'm not even asking to use code, because I have code interpreter off. Yeah, not great. Either way, if we're just judging based off of token speed on the T-Rex, it's great. We'll click on the T-Rex again, at least to try to end this review on a positive note. Although, again, the thinking time is not necessarily a positive thing for a model called Lightning. But at least the token speed is high when it actually gets to it. So there it is. It's actually, I might as well just spell out what it's saying. It's the thinking process. It's generating all the thinking. And there we go. So I know I'm being critical on it when it comes to the actual decode speed coming from thinking. I guess we could turn off thinking display and just have it actually spell out the information, all the info and results. Maybe that would be better. But either way, token speed is fantastic. It is definitely over 50. I'm saying 70 or 80. This is an impressive model. Just right now, don't use it to open files. And let's do it one more time. This time I will actually open up the thinking so we can actually see it think, to show that prefill is actually pretty fast. So let's open up actually a new chat, and then I will say, tell me a fun fact about the Roman Empire, and then open up the thinking here. Oh, there we go. See how fast that prefill is? So it's actually telling us what it's thinking about and what it's going to say. And that generation is definitely running at 60 or 70 tokens per second immediately. And then when it gathers all that information and tries to make it either concise or appropriate, then it spits it out. And all of that thinking came out to 2 paragraphs, or a sentence in a paragraph. But at least it was thinking about all this information there, right? So anyways, Nemotron 3.5 Lightning, quantized down NVFP4, 3 active. Thanks a lot.